welcome back. In this video, we'll be looking at solving some harder trigonometric equations with multiple answers. So, this is once again where your knowledge of multiple angles and four quadrants will be much use to you to answer these questions. So, before we go ahead, I always ask my students this question. I tell them answer this problem. So they I show them this working out here, and I tell them just tell me what's wrong with this answer. Is there a mistake in working out the problem here? And let's read the first example together. Okay. So actually, this is not an example. This is just review of what we should know by now. This is proof of why these two angles or these two blue triangles are equivalent to each other when you're using sine, and those red triangles are equivalent to each other when you're using sine. These again, I'm not going to repeat myself. These are equivalent triangles that you can use to find multiple answers to your equations and problems. Okay, so if you found one of the angles is in this quadrant, you know the cos of this angle here is equivalent to cos of that angle there. So try to figure out what's the angle, obtuse angle there, and what's that's the same as this reflex angle here. Alright, and same goes for tan. These two triangles are equivalent for tan, those two triangles are equivalent for tan. So try to use this and verify this for yourself. Doesn't matter how many times I repeat myself, you have to verify it for yourself so that it will sink in. Okay, so let's read this problem and solve it. We said that in these questions there are multiple answers, and this range 2 theta, remember, that's telling us that there's actually two periods of cos within 360 degrees. So we actually need to say, because of 2 theta here, I need to look at the range of my, when I'm going to solve this problem, I'm going to use inverse cos, and inverse cos is telling me what is cos. Now the calculator doesn't know how many periods you're looking at. So you actually say if theta is doubled, then 360 must be doubled, and so should 0. In this case, 0 times 2 is still 0, but the point is to look for all the values within this range here. So then now we can take our cos inverse. Now we can say solving this equation leaves us with 2 theta on the left and cos inverse of 1 minus 1 on the right. Now cos inverse of minus 1, if you put it on a calculator, it will give you 180 degrees. So I know 2 theta is 180 degrees, and actually that's a positive 180 degrees, and taking 360 minus this answer will give us the same answer. This is the only answer that when you it doesn't have an alternate value, because it's right at the minimum and 360 minus 180. So I'm saying that using that trigonometric identity of cos of theta equals to cos of 360 minus theta doesn't quite help us, but that's not the point. We can still add another 360 to it because we have to go and find all the answers within that range. So adding 360 to that leaves us with 540, but if we add another 360 to that, it would take us beyond the range of 720. You can test it for yourself. 540 plus 360 is 900, which is not what we need. I'm just going to put it here and cross it off because I'm saying that it's beyond this 720. Now, do you understand why we went ahead and doubled that range? Because we have these 2 theta here, and we are going to divide these, and they will be halved, and their final answer would be 90 and 540. Sorry, this is not a plus sign, comma. So 540 divided by 2 is 270, and that is less than 360. Okay, so now we went back and divided it by 2. We are within the range that we want. Okay, so these are the two answers to this problem. So I'm gonna show you a neater way of writing the answer. You multiplied the range, you took cos inverse, and this is 900 that I crossed off here, and this is the final answer. Alright, and the graph is showing us that you can confirm it for yourself. This is 90 and this is 270. Alright, so now I have also made a video. If you do have a graphic calculator, you may be able to use it. You can type this in your on your graphic FX. There's FX. This is for CG50 only. Okay, this graphic calculator does tell you, if you learn how to figure out the commas on your button, go under this menu options, calc, and solve. And there's a video I've made particularly just to use that. You can watch that video and figure out how to figure out these answers. But in the exam, they don't give you any credit for using a calculator to tell the answers. They might give you might get one mark just for final answer here, but the working out, showing that you know what you're doing, is the important part that will get you the high marks in the exam, and that's important. That's what I wanted to learn here. So once more, in this question, we are sorry. In this question, we have 3 theta in our work. Okay, so 3 theta is inside the bracket. So what you need to do, the very first step is say, I need to triple my 360. I'm gonna get 1080 there. Alright, so I need to go and we find all the answers from 0 to 1080. It's crazy, but that's what we need to do. So we write here 3 theta equals to cos inverse of 0.5. Now, when we take cos inverse of 0.5, we just write this for you like so. We're going to get the value of 60 degrees. Now, once you found 60 degree, you're gonna use this identity that's for cos. Alright, so 360 minus 60 is these are the two principal values, 300, and this is one angle here, 300, and that's another angle. So then for these principal two values, all you have to do is just add 360 to each of them, because it will repeat itself. Alright, so we're adding 360 to each, so all the way to 1080. This is the largest degree, that's still less than 1080 degree. Now what's the next step? Now is time to perform division by 3. Now you're going to get these angles here. What most students make errors with is that once they get 60, they divide it by 3 first and then add 360. That's not gonna do the correct calculation. So I'm being devil's advocate here. They they might even they might even go and find 300 and 300 degrees there. They do this. They say, okay, now I'm going to solve this equation. Theta is, they divide this by 3 and they say 20, and then they're going to add 360 here. And they do the same thing. They say 3 theta is 300. They found the first two principal values correctly, and they're going to say theta is 100, and I'm going to add 362. What's wrong with that? Well, this is not going to be 460 is not the right answer. None of these answers are 480 because what's wrong with that is that you are adding 360 where in fact the difference there, the scale factor for these graphs is not 360. They've been scaled down. They've been squashed together. The gradient is higher, therefore the difference between these points is actually not 360. You don't need to know that. This is the correct way of solving the problem. You don't need to know that they are actually 120 degrees apart. Alright, so if you check actually these two, this is not the correct way. Just follow what I taught you up here, add 360 to the first two principal values, and then just bam, swoop, one fell swoop will divide everything by 3 will work out the answer. Alright, so I think that, alright, there is one more example here. We've been asked to solve this equation here. I've written it right in the beginning of the page twice here. So here you're going to look at what's inside the bracket here. We got 2 theta and take away 35 degree. So you're going to build up to that expression there. First, let's times everything by 2. So we get 360 here and negative 360 there. And then we're going to take away 35 from both sides of the inequality. We're building this inequality as it is, one step at a time. Here, we just times by 2. Here, we're going to take away 35 from both sides. So 160 minus 35 is 325 here. That's less than or equal to sign. And this minus 35 is negative 395. Okay, so this is the range that we need to solve the equation for. So sine inverse now, we can take sine inverse of both sides and write it like so. Now, let me wipe off what I just explained there because I've created that there for you. So sine inverse of minus 1 is going to give us one answer, negative 90. Alright, so this negative 90, you say I am going to take the identities I learned. 180 minus a minus 90 gives us 270. So its equivalent value 270. It don't forget the okay other places value, yeah. And this original 90 is also useful because it is within that range. Bar range has negative angles as well. So then you say for each of these, I not only I can add 360 degrees, I can subtract 360 from each of them as well, because we need to go beyond the just positive range and go into negative values. So you add 360 to both and you take 360 away from both of them. Okay, so that number 630 is beyond the range that we want, but we can, and this is beyond the range that we want, but we can take away 360. Well, these their useful numbers therefore are just 30, just the negative 35, negative 90, and just 270. So none of those, this negative value is beyond the range here, and this 630 is beyond this range here. It's beyond the upper limit of our inequality, so it's useless. So then, now is the time. Remember when we took sine inverse, the negative 35 remained where it is. So now here is when I'm adding that 35 to cancel away the negative 35 here. So now you're dealing with these two answers, negative 55 here and 305. Sorry, I feel about to sneeze. So the final step is to divide by 2 and you get these two answers there. Alright, so this particular question had only two answers there and I've graphed them for you there. And alright, so you can use your graphic calculator to check the answer, but don't cheat because you need to show you're working out and know what you're doing to get full marks in the exam. Alright, good luck practicing. I'll see you in the next video.